Rung 2 contains a software-generated make instruction examining output Q1 and a break instruction examining input I5, the F1 auxiliary contact in series with output Q3, the red pilot lamp. You'll note this rung has effectively turned the red pilot lamp into a contradiction indicator, meaning that the red pilot lamp will turn on only if output Q1 is being asserted and the F1 auxiliary contact is not closed. As can be expected, one shouldn't anticipate this scenario during normal operation, given output Q1 is in fact energizing the F contactor coil. However, there are scenarios, momentary and maintained, that will result in output Q1 being asserted and the F contactor failing to close. Can you predict those scenarios in which such a contradiction might be observed? By all means, pause the lecture and think about this before we place this system in operation and test this program. Here's a quick hint. Think of response time and those hardwired devices that override the program for protection purposes. When the program is downloaded to the target device and placed into operation, we can observe its behavior and simultaneously monitor the program using a live communications link. Note the two videos are synced up, however there's a noticeable lag at the monitoring utility. As can be expected, when the selector switch on input 1 is open, the F contact coil is not energized and the motor is off. Output Q1 is not asserted and the F1 auxiliary contact indicates that the F contactor is open and the red pilot lamp is off. When the selector switch on input 1 is closed, the F contactor coil is energized, the F primary contacts close, and the motor turns on. You'll note the red pilot lamp briefly blinks on, indicating there's a fleeting moment of time where output Q1 is asserted and the F contactor hasn't fully closed. Once the F contactor fully closes, the contradiction resolves itself and the red lamp turns off. When the selector switch on input 1 is reopened, the F contactor coil is de-energized, the F primary contacts open, and the motor turns off. The system behaves as anticipated for normal operation. Let's now examine its behavior during emergency stops and overloads. When the selector switch on input 1 is closed, the F contactor coil is energized, the F primary contacts close, and the motor turns on. Again, you'll note the red pilot lamp briefly blinks on, indicating there's a transitory period that output Q1 is being asserted and the F contactor hasn't fully closed. While in operation, opening the estop directly depowers both the field input and output devices without reliance upon any programmed instructions to do so. The F contactor coil is de-energized, the F primary contacts open, and the motor turns off. If input I1 is in the closed position when the estop is reset, the F contactor coil is immediately re-energized, the F primary contacts close, and the motor turns on. Let this be a cautionary tale about the limitations of emergency stops in two-wire control circuits. If the two-wire control system is repowered with the automatic input being actuated, the system can spring to life without warning. Let's now examine the system's response to an overload event. As previously, when the selector switch on input 1 is closed, the F contactor coil is energized, the F primary contacts close, and the motor turns on. Again, you'll note the red pilot lamp briefly blinks on, indicating that there's a transitory period that output Q1 is being asserted and the F contactor hasn't fully closed. If during the course of normal operation an overload event occurs, in this case I'm simulating an overload by manually testing it, the open overload directly depowers the affected field output device without reliance upon any programmed instructions to do so. The F contactor coil is de-energized, the F primary contacts open, and the motor turns off. Note, however, output Q1 is still being asserted by virtue of the maintained closure of selector switch on input 1. A potentially deadly situation is coiled and waiting to strike when the overload cools and is manually or automatically reset. Luckily, the logic in rung 2 indicates a contradiction has occurred in that output Q1 is asserted, however the F1 auxiliary contact is not closed. The red lamp is on, indicating that something is amiss. An operator or a technician can take the necessary precautions and lock out and tag out the system to investigate the source of the overload. As can be expected, when the overload is reset with the selector switch on input 1 closed, the F contactor coil is immediately re-energized, the F primary contacts close, and the motor turns on. Let this again be a cautionary tale about the limitations of two-wire control circuits. If the system is reset with the automatic input actuated, the system can spring to life without warning. Alright, that's about it for this quick application exercise. In conclusion, we programmed and tested a simple PLC-based two-wire control circuit. We demonstrated its behavior during normal operation and its response to emergency stops and overload events. We learned that the hardwired estop and overload can directly override the PLC without resorting to programmed instructions and additionally examine the limitations of two-wire control circuits during emergency stops and overload events. Finally, we included an additional rung on our two-wire control circuit that indicates when the PLC is asserting an output, however, fails to receive confirmation. This indicator demonstrated that there is a transitory period of contradiction accounting for the real-world response time of an electromechanical system and is only continually asserted when some outside event, like an overload, is overriding the PLC program. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.